Alright, so, there we go. Hey everyone, this is Gio from Productions², and tonight we're going to do something a little bit different. Been working on stuff for Odyssian Void a bit, and really the stream should be on Odyssian Void, our Odyssian Void channel, but I'd rather do it over here for now. So what we're doing tonight is we're going to be trying to kind of flesh out and then start working on a supply and demand simulator that'll form the basis of part of the economic system for the economic proof of concept, that economy proof of concept I've been working on for like the last, I think year and a half or something. Not really a year and a half. I think in actual working hour terms, it's like more closer to a couple of weeks, I think, is the actual amount of time I put into it. I think, well, maybe months. But that's what we're doing tonight. So let me go grab, I think the system one's empty. Yes. I've also been working on Triasha a little bit lately. Starting and reviving a lot of stuff I haven't worked on for a while. So let's just call this SD checklist or something similar. Called checklist for now. Basically, it's just going to be kind of like a design document or something that's pretending to be one, so we know what the hell we're doing and aren't half-arsing it all the way through it. So let's talk about supply and demand economics and things like that. So in proper functioning economies, you have a supply and a demand. So the demand of an item makes companies produce that item to sell, which lessens the demand and generates some money. So generally, that's kind of what we want to do in the game. We want to have some resources that are used for something, that are being consumed. So that's how economies work. It's on consumption of materials, not production of them. You can produce all the stuff you want. If it's not being consumed, then it's worthless, basically. So we want to create something that we want to create a system that takes something. For instance, let's say just iron. Let's say we have a resource called iron, which actually we do, but say we have iron, and let's say that iron can be used to make the following things. Can be used to make steel. Can be used to make blocks and llamas, because we need more llamas. So these three things iron is used to produce. So when these things are made, iron is consumed, and then these are used for other things as well. So like steel can be used for construction or something, and this doesn't really necessarily have anything to do with the game. It's just, plating and llamas, I don't know. Alright. Iron llamas, nightmare fuel. As iron is consumed, the value of it will increase because the supply is reduced. So, therefore, demand increases, and therefore the price goes up. So, what we want to do for a simulator of this is we want to say, okay, we have a resource or commodity. I think that's right. No, it's not. There's a Y missing and some other weird things. Commodity or whatever that we are producing or that is being consumed. So when it's consumed, based on demand, increase the value of the, let's call it RCW for short, because I want to retype that up again. So when it's not being consumed and is being produced in bulk, decrease the value of the RCW. So basically, that's basically what an economic simulator is at the very core of it. You have stuff that's in the game, it's used to make things and is consumed, and then producers produce more of it, generating income, generating money changing hands, and all the stuff that happens in the economy. And that's really, at the very bottom of it, that is what economics is. It's items being consumed based, and then the price of those items that are being consumed changing depending on what the demand is and what the supply of that item is. And so yeah, that's the design document there, I guess, really. So how do we go about actually doing this in code? That's another interesting question, because it's more complicated than this. Because first of all, you have to determine, okay, at what point do we have a scale or some sort of sliding scale that says that at this level of demand and this level of supply, the value changes by this much. So you have to figure out some sort of balance. Then you have to figure out, okay, now that we have the scale determined, we have to put in ways for these things to be used and things to be made from them, and things to be and prices to be used to be sold, and buyers and suppliers and production facilities and manufacturing companies and yada yada. It becomes a really hairy mess when you start thinking out more abstractly like that. So what we want to focus on in this is we just want to make something that will take resources, or will RCWs, consume them, produce them, and assign a value to them based on supply, demand, demand. So that's essentially what we want this thing to do. So let's go ahead and get Visual Studio open. Now it's going to start a new project. Empty project. Call it SDSim project. I don't care about a Git repository for it. Alright, so first things first, we need to add in our main file. The file that will actually, basically the file the program will execute from. So let's call it SDSim. I used to call it main, but I've gotten in the habit of naming it the actual project name, so it makes more sense than saying main. It's like, okay, this is the one, this is the file where the project actually runs from. It should be called what the project is. Let's see, it's CPP, that's fine, boom. Alright, so first things first, we're going to need to do some includes, IO system, gonna need, or include, not includes, include string, definitely probably going to need vector. Well, you might not need vector because that might be in a separate class. We do need IO, we do need string. I don't think we need to include system or anything like that, because that should just be inside automatically. Include. Did I type it? IO system. IO stream. God. I have not coded anything in C++ for a while. Just kind of remembering a few things here. IO stream. So let's see. I want to go int main return 0. All right. So what do we need for this? So this is going to be like the visual aspect of it, or it's going to be where we're going to do menus and loops and things like that. So obviously we need to do a loop here. So let's say process loop. Well, first let's go ahead and create some vars. Boolean bool b quit. We'll say did quit. Did quiet? No. Did quit equals false. process loop while not B did quit. So while we have not quit the simulation, you want to process this. So let's see. So what do we need to do this there, but we need to do things before this to set the rest up. So we'll say set up functions. So now we need to create some classes. So first thing we need to do is we need to create a supply demand class or economy class or something. Again, something similar to that. So what do we call this? Supply, I guess, well, it's not really an economic similar, it's supply demand similar. So we'll say SD processing or something like that. SD proc. That sounds good. So have our, let's see, define our fndef SD proc h underscore h. Define SD proc ndif. Alright, so class is SD proc. That should be lowercase c. I'm used to writing things in VB now. During my day job, I work almost exclusively in VB these days. Because I work on a VB ASP portal for the company I'm working for now. And it's a frelling mess, I will say that now. The person that made it was not a very good programmer at all, and there are all kinds of just horrendous, nightmarish things in it that make me want to scream sometimes. But public, obviously we need the constructor, make an empty constructor, public. So processing. So what do we want this? So this is going to basically handle the taking each commodity we're going to make, or resource, or whatever. We'll call them commodities because that's like, it's a little more sense in terms of economics. Because in an economy, everything's a commodity, and the value of that commodity is based on supply and demand. So so this one would process commodities. Misspelled or not. Public void. Starting to come back to me. Public void. What doesn't it like about that? Oh, definition, yeah. So we still have to do the definitions for this, right? Forgot that it yells at you when you don't have a definition for a function declaration. So we have this now. What do we also want to do with this? I mean, I guess we do have to have, well, that it'll scream at me for this, but we have to have a vector of, say, this is where we need to put the vectors in that. So we need a include string, and actually if we do this, we don't need to include it over in the main file, because it'll automatically be added into it when we import it. So actually we just change this to an import, or actually it's include, not import. Include stproc h. Well, yeah, the header. Okay, so we have the vector, and then I guess I'll put it here for now. It'll scream, but whatever, it can shut up for a while. Commodity.h. Alright, so public void, public void create commodities, commodities. Then we'll have a private section where we'll have a vector of commodity called commodities, I guess. So Let's go and create the commodities class. So if and def commodity. I don't think that doesn't seem like it's the correct spelling of commodity. Oh yeah, I guess it is. Never mind. It's one of those weird words that's like, that can't possibly be spelled that way. Commodity H and if. So, and actually if we go back to here, we don't need strings. We're going to put it over in commodity. This is a way to kind of chain in your includes, so you don't have to do a bunch of includes everywhere. Include string. So class commodity public. So we'll have a blank one, and then we'll also have one where we're going to set up the actually set it up with it. So string. Almost forgot. Using std string. Need that in there. String cname int float c value. So the value of each commodity per unit. I think that's all we'll do. So basically it's the base value of the commodity. Well, let's see. So when we create it, it'll have a base value, but we'll update that value as we go on, or decrease it. Change it, we'll update it as we go through with all the other stuff. So we'll have to create something to also modify that. So let's do private. Actually, we don't have to say public, do we? Because it's already in the public section. We just got to say void. So again, I am used to coding in VB now. Private, so we have string cname, com name we'll call it, just to differentiate it from that parameter passing through string, or float, com value. So now we need to have a function that will allow us to update the value of c value. So void update value. So we're going to pass through a string op, and then we'll just keep this pretty simple and just do a simple one instead of something like I did with the other one. Like in my other larger proof of concepts and also in the game, there's a utilities class that has it's a namespace that has I think it's a namespace. It might be a class in the current version of the game, but in the proof of concepts, it's a utility namespace that has basically an update thing that updates a whole bunch of stuff, and it does all kinds of interesting stuff. Kind of combines all the stuff that I used to do just by if statements into that, and that way you just pass through values and it processes them. But in this case, we just need something pretty simple, so we're just going to say float new val. Right, so then we need string get name and float get val. Pretty simple. Alright, now over here, I don't think we really need to, well, I guess there's a couple ways we can do this. We can either return the commodities vector as a return from a function, or we can do the output here instead. In my opinion, the way I would do it is I'd return it to the main class, because that's where the IO stream is at, instead of putting an IO stream in here too, just because that kind of starts breaking and encapsulation because you're doing something that should be done somewhere else, and really, even the writing should be done in a different function than the main function. But that's getting a little too meta for the purposes of this. So we'll just do a return of a vector of commodity. Get commodities. Okay. Now, what I'm hoping I can do is I can just select all these, hit this, and go to quick actions and go on create this, and it'll populate SD sim. Perfect. Good. So that's interesting. Vector. It's not templates. So, do I need to... Let's see, it's on vector. Okay, vector is undefined. So, why are you undefined? Commodity, save. And it might be because... Well, let's see, commodity... Oh, Jesus. Typos, vector. And, using std vector. There. And if, I think, has to have a semicolon. Or no, this has to have a semicolon. Vector, holy crap. Okay. Alright, there we go. Problem solved. Yeah. Alright, so let me do the same thing with these. Let's go to quick actions. I think this is something new to 17, or at least it's something that's working in 17 that never got to work in 2015, but it's very useful. Especially when you're first starting, because then it'll just populate everything, you just fill in it, what you need to. Alright, so we have commodity. I'm just going to one-line this because it's just going to be a blank constructor, so we don't need anything there for this. We want to say com name equals cname and com val u equals cval. Okay, and then update value. So, if op equals add without the capital D, then com value plus equals new val. Now you could say that what we could do is say if this is a positive or a negative, do something, but then you have to handle the setting. And it gets a little bit interesting doing it that way. It's easier just to pass through an operation. That way you can do things that you might not be able to do otherwise. Like, for example, multiplication division. How do you handle that when you're just doing it by the sign of it? Alright. So now this one's going to be a sub if because we need to handle if we reduce it and it goes below 0, we want to set it to 0. It shouldn't ever happen because it's the value of a commodity, but it should go pretty near 0. But again, we have to handle that just because until we figure out the edge cases around how the value is decreased and when it's decreased and the scaling of it, we're going to have to handle, make sure we're not giving people money to take their crap from them. Or rather, giving people money to take our crap from us. Let's put it that way. It's a better way of putting it, because actually the other way is what we want. We don't want to be giving them money and our stuff to them. Saying, here, I'll pay you to take this. That's kind of, government work kind of stuff. So sub set. Oh, wait, damn it. Kind of skipped over what we're supposed to do. So if com value minus new val is less than 0.0, f then com value equals 0.0f, else com value minus equals new val. Then else if, and you could just do else here, but in this case we're going to do else if because I like doing it to be more specific than just saying else. Else set. It's pretty simple. Com value equals new val. Alright, so there's our stuff there. So I just need to return com name and then return com val here. Value. Alright. So there's our commodity class set up there. Now this is basically just going to store data. We're going to generate commodities to store in a vector that will then be updated in that vector as things happen within the loop. We will have like we'll create a static list of commodities that'll be used to create them, but this way we'll be able to store them here and not have to worry about and be able to do them in a more valid way and something that's not quite as static as just putting values into an array and then, or in either an array or a vector and then modifying them directly that way. This way we can have, the name can be static, but the value it starts with, the value of the thing, the starting value of the commodity can be randomized somewhat. Speaking of which, we're going to need to add a random function in too eventually. We'll get to that in a bit. So now, the actual processing function. So again, this is an empty constructor, so we can just do that. So process commodities. We'll come back to that. Create commodities. So in here we're going to create a static list, if I can spell correctly, of stuff. Lit. Static list of lit stuff. Alright, so this is going to be a string array, so string stuff list equals, actually it's the other way around. And we'll actually give this a, we'll create 5 things, I guess. So, iron, copper, what else? Llamas will make a return. Let's say and let's make steel and alright, so only one of these things is really going to be used to actually be used as a thing that's being created by other elements. The iron and aluminum together, that makes steel. For the other things, we'll have to add things in later, but for now we're going to work with this list here. So for each string list item in a stuff list, one thing we'll need to do over here, well, do that. We'll need to create, in here we'll need to create a commodity. So, commodity, new come on, equals commodity, so list item and then a value. For now, we're just going to put 0.0f here so it won't scream at me. And then we also need to have a float. let's call it base val, which will equal, eventually will equal get f range, or rand, I guess. And then we'll just pass through some, like, 1.25 to 4.50 or something like that. Some random values. And then I guess we'll pass that through here, actually, now. Okay. So, for each thing we have listed here, we're going to generate a commodity item and create a base val for it. Then we're going to add it to... actually, one thing we probably should do up here, this won't be an empty constructor after all. We need to initialize the vector. So, commodities equals... I think there should be a new there. Capital C. So operating types, commodity, or not. Unless I didn't see value vector commodity equals new vector of commodities equals new vector commodities. Okay, so not new. That was a little bit of Salesforce creeping in on that one. What have we got? What's going on? Oh, right, forgot there's an update. Forgot there was an update for my Tesla today. Car was just telling me that updating, charging has been interrupted. And that's why. So we have our, we're initializing it here so we don't have a null when we're trying to process it down here. And then we're going to add it. So commodities.add new com. All right. So we're going to push, not add. So we're going to add the commodities crate to it, and then that'll form our list for our supply demand. Let's see. So now we need to, well, let's see. We also need to add, I guess what we need to do is we need to add in some other stuff here as well, now that I'm thinking about it. We have to add in a supply value and a demand value. So basically, the number of units that are available in the economy and the amount of units that are being demanded for consumption by the economy. So that will be we'll make it an int just to make the headache less. So com supply and int com demand, which we'll also need to have setters and getters for. So int get supply, int get demand, void update supply. Okay, so as with before, let's highlight these, quick action, create, come on. And basically I just want to do the same thing here, we'll just rename what's there to what we need. So find, replace Oh, last time I had this open, I was working on GeoRO stuff, apparently. So, com value. And replace it with com supply. And do the same for demand. Alright. And then return com supply. And then we can also fix these so they are one-liners, since we just have a one-line thing going on. It's too bad you can't format. I don't think you can format these the way they're formatted in C# in some cases, where you have like a this kind of a thing, and you just say basically you have the function definition there, and then you just do this, and then we'll return that way. But I don't think you can do that. That shorthand isn't available here, which kind of sucks. It's a very interesting way of writing it. It doesn't really improve anything. I mean, you don't have to put the brackets in, braces and curly braces in, but it just makes it look a little bit more interesting, I guess. Okay, so we have let's see, we have our getters there, we have our setters. All right, so now, oh yeah, we have to update the constructor as well now. And C supply and C demand. Oops. Go ahead and add those into that constructor. And then com supply equals C sup, and com demand equals C dim. All right. So back over here now, we have to do an int base supply equals, well, base sup, we'll just call it, equals get I rand, and int base demand equals get I rand. Okay, and then we'll also put in our stuff here. Okay, so now would be a good time, I think, to bring over the random functions and things like that. So first thing we need to do is we need to create a range header file, range class. So fn def range come on, and if actually no, this just has to be a struct. So int r low, rather we should say I low, int I high, float f low, and float f high. That way we can do int and float ranges within the same range struct without having to create another one for it. Okay. And then we need to do a class, not really a class, but it's more like a static code file called rand. So we will include range.h. We also need to include a few other things. And for that, I'm going to need to pop over to one of my other files because Productions, I've completely forgotten what those are. I know it has to, there's like, has something to do with like seeding or something like that. There's some weird new. It's not like the old way of like using the seed within a random or a rand or something as time. There's a new thing that was put in C++11 to do all that more easily. But I cannot remember it at the moment, so that should be fine. Should be in there. So, random. Nothing in there because it's not a class, it's just a code file. Oh. Well, joy, there's nothing there. Maybe it's an util. Oh, that's right, I said I moved it to util, didn't I? Alright, so we need, I think I might need algorithm and math. Well, we'll see. So for sure we need these two. We don't need the iterators, but we do need these. So there's those. I do think we need algorithm. We might need math as well. So settings H, logging H. Let me check settings real quick and make sure I don't have anything over here that we might need as well. So we just have range over here. String vector IO, string map, and range. Okay. Maybe I need to go look at a slightly older project real quick. So let's head back to 2015. It's definitely not in there, so it might be a header in this one. Random. Yeah, here we go, random. So we just have random and it includes this stuff automatically. That's interesting. Oh, include random. That's what we need. It was probably over there and I thought it was something else. Stuff what we needed, so we don't need this actually. At least not yet. Probably won't need them. Not here anyway, we'll need them somewhere else probably. Alright, so there we go, we got these. Now we need to have our functions here. We probably don't even need, well, do we need range or no? I guess this one's not functioning based on a range. Actually, no, yeah, let's do that. So, actually, let's call this I range, int range. So, I rng.I low. Just to make it look a little bit cleaner on the calling side. So we only have to pass through one parameter instead of two. That's kind of a cheap thing to do all this code for, but it looks better and it's a little bit easier to understand that way. And then we just need to change this to an F. F, and FF. Alright. And over here, just gonna include oh, it's rand, not random. and get RNG. It's all about shortening things up here. Rand, where's that? I thought so. Thought I hit it a little bit too many times. All right, so get FRAND because it's oh yeah, class definition. Well, it's not really a class definition. It should work that way. So it should be a static. Do I need to define them as static? Get IRAND, get FRAND. Turns an int. Get IRAND, not range. That's why. There we go. So, huh. So here's a chicken and egg question. So in order to have a range, we have to have two values. In order to have two values, we have to have a random. So what's the purpose of? I think we just create a paradox here. Call Doctor Who. Needs to get over here and fix this. So I think maybe we just want to pass through the values. For now, anyway. So I'm just going to undo everything I just did. Blah, 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 blah. Okay, redo that part. Rename these to rands instead of ranges. But keep everything else the same. Alright, and then so supply and demand. So initially what we want to do is we want to have the supply be greater than the demand. So we'll say that we're going to have between 15 and 45 units of each of these. And the demand will be between 10 and 20. So I mean, there's a chance where you get something that's higher demand than their supply, so that's a little bit of a variation, but for the most part it should be higher supply than demand to start with. The other thing we have to do is we have to create some kind of matrix or something to indicate that, you know, okay, to make steel we have to have aluminum and iron, and how many units of that we need to make the steel. Again, this is just pure supply demand. It's not taking into consideration, like, for example, the larger economic proof of concept I'm making does, like, trading parties, trading resources and money, or credits or Zarn or whatever, between each other for the things. It's just saying that there's a magical pool of this resource, and there's a magical pool of this resource, and there's this thing we want to make, and it requires these two, so we take some out of the pool, and the value of those resources in that pool goes up or goes down. That's all this is going to do. So we have that. In this case, steel is the only thing we have anything for, so let's go ahead and, I think it would be good to make this as a, well, let's see. What would be better, matrix or map? So what about a map of vectors, which by any other name would be a matrix of sorts. A matrix is really a two-dimensional array. I mean, in terms of that, a map is a matrix. A vector of vectors is a matrix. A two-dimensional array is a matrix. It's all just about the structure of the items. So like this here is just an array. If you put in like another one here, say like 1, that would mean that for every one of these, there's going to be another. Basically, these are columns, and there's like a row underneath the column, if you will. Or maybe a better way to put it would be that each one of these is a row, and then there's going to be a column, one column after it. So you're going to have iron and then something else that's part of iron. You're going to have copper and something else that's part of copper. But in this case, I think a map would work best. We're not going to have multiple entries of them. So like the reason we'd use a array matrix or a vector matrix is if you have a chance, either you have a chance of, or you don't really care if you have the same thing in it twice. So like if you have if you iron in it twice, for example, if that's something you want to have happen, then that's how you would do that. If you want to say that you can only have one type of something in it, then a map's better because there's built-in things to not let that happen. So you don't have to check to see if it's already in there or not. So in this case, we're going to use a map. So we need to include, actually we'll do this in the header. I like to do the stuff in the header now in terms of the includes, because that way it gets propagated through the include chain for the header files. So include map, and we need to add the using std map. Actually, I think we need to also have using std, I think it's make pair. I think, no, it's not it. It's not how you define it anyway. Where's my utilities? Oh, just std pair. Okay. Really? That's all we need to do? Let me see. Where would we be using that stuff at? Begin, insert pair. I guess it's just pair. Okay. Not make pair. Make pair from something else, I guess. Alright, this is just pair. Pair it is, without that stuff. And semicolon. Okay, so back over to our implementation file. Alright, so, we need to make a map in here as well, though, that we can use for setting stuff. Map strings, so map of strings, and then within that's going to be a vector of strings. So basically what we'll have, well, so a map of string, so the key will be the commodity we're creating, and the value will be a pair, a string int pair. So the string will be the name of the other the commodity we're using to make it, and a vector of pair actually. I didn't think I said a vector of pair. If I didn't, that's what I meant. So we'll have the string be the commodity, and the value of the pair, well, the key being the commodity, and the value of the pair being the number of that commodity to use. So we're kind of going a little bit matrixy here with this. Not matrix, the movie Matrix. Vector pair string int. Okay, and then we'll call this, let's kind of craft list, because that's what we're going to do. What don't you like? Explain. Oh, we're missing we need 3 angle brackets, not 2. And for some reason, there's a space here that shouldn't be, and really there shouldn't be one here either. Okay, so now that we have this monstrosity we've created, we need to go about initializing it, which is easy. Filling it will not be. So, craft list. You could probably do something easier with JSON, but I don't think that JSON is compatible with C++, or if it is, I've never used it before in C++. Now, if we're writing this in JavaScript, on the other hand, I would kill somebody before using anything other than JSON to do this kind of a thing. But so we need a vector of, nope, we need a map of string, vector of pair of string int. Okay. So now now we need to do that. So the only thing right now we're having that's going to be any craftable, so to speak, is going to be the steel. So all we need to do is we need to create a pair. So we're just going to create it in here, hard-coded in here, instead of doing some sort of automated process like with the item list or whatever list item thing here, the for each loop. So pair string int, let's call it p1 equals pair string int, and then steel, or rather not steel, iron, and 2. Hopefully that good. I was kind of doing that by, I was pulling that one out of my arse because I couldn't remember exactly how to initialize that correctly, even though it was over here, I suppose. Yeah. So string int p2 equals pair of string int aluminum. Sorry, people from Britain, it's aluminum, not aluminium. And then 1. So basically 2 parts iron, 1 part aluminum for steel. I don't know if that's actually what it is, but that's what's going to be in this case. Chemists need not apply. So now what we need to do is we need to stuff this into a vector. So vector of pair of string int pairs. Yeah, we're going totally lit with the naming conventions here. Variable names equals vector of pair of int string int yes, of course. I wish it would stop putting in annoying things like that. Okay, and then pairs dot push back. Whoa. P1 and pairs dot push back P2. And then we need to shove this whole thing into a lovely map. So we have our craft list already ready for that. So craft list dot add, or is it insert? It's not add, it's not push. Yeah, I think it's insert. And then we want to put in steel, and then pairs. And I knew it wasn't that. So inserting it into a map. No, that's what it is. Insert. So what don't you like? So no instance overload function string pair. So map of string vector of pair string int. Okay, so let's go ask the mighty Google real quick. So maybe we need to do something different. Insert C++. So make vectors. Make vector. So let's have a look at this. Okay, scalar vector string. So map insert pair. Oh, we have to create a pair. Derp. So, pair of string vector of pair of string of int. Okay. There we go. There we go. All right. I almost forgot the most important thing about that. So that has to be a pair. So we have our pair of string vector pair string int. Yeah, that's enough to make you claw out your eyes, I think. Okay, so now we have that. Let's see, so the next thing is, we got all this, we're creating our craft list, we're creating our commodities list. And next we need to handle processing the commodities every turn. So, now, what's going to happen is that every turn we're going to modify the value of the supply and the demand. So, arbitrarily, of course, because we're not tying this to like anything actual physical, it's just magic. It is economic magic. So all we're going to do is we're going to say for each commodity com in commodities. So for each one of those, actually we need to make this a reference that the values will actually update inside of the inside of this, so that when we change something, it'll be changed in that as well. So now, for each commodity, we would basically want to just do this again, kind of. Except instead of doing this, we're going to call, we're going to basically create this again. We will create this again, but it's going to be called something else. We'll call it updated, and then updated. And in this case, we're going to change this to smaller values. So we're going to say 5 to 16, and the demand will be something in between there. So we'll say maybe 7 to 12. So that way we can have outliers that will increase the supply, and sometimes inliers, if you will, that will sometimes cause the demand to exceed the supply. Next, we want to update those. So com.update supply. So the op is going to be add, and we're going to pass through upd sub, if I can get the right keys pressed, and then com.update demand, add, not sub. I think I said sub before I meant add. I typed the right thing, said the wrong thing. And then pdem. Alright. Sup, not sub. There we go. So we're just basically updating those, and that's all we're going to do with that. Now what we're going to do is we're going to have a different function called process supply demand, so process SD, I guess. close that peak. Alright, so now here's what this is what we're going to do now is, so what will happen is we'll have process SD go first. It will, for every craftable item, so we're going to do a for each loop on craft list. We're going to create a random number of that item if we have the resources to do it. If the resources don't exist to do it, then we'll create, we'll basically do a while loop for this. And while fabrication not valid or while fab invalid, continue to process the loop until we get a number of steel to produce that fits within the confines of what we actually have available in our magical pool of resources in the stuff list, in the commodities vector. And then make those, and then remove the constituent resources from the commodities elements that they are a part of, and then process the value update for that commodity. So first thing we need to do a for each, and in this case we don't care about updating the value, so we'll just say for each pair string vector pair string int. I already hit myself for doing this. We'll call it craft. We'll say craft item in craft list. So is there a way we can do this more? So that's with an iterator, kind of, which we're not going to do with this. Well, it could do it, but we can just go paired out first, paired out second, I think. Alright, so the first thing and I'm not even sure if we need the first. Well, yeah, we do, because we need to add those to the thing. First thing we need to do though is we need to set up a bool up here. Bool b fab valid equals false. So while fabrication is invalid, continue. So, first thing we need to do now is we need to have an int and items equals get I rand. Now we'll just say 1, 2, 3. So we'll craft up to, I'll say 1, 2, 8. Let's do 10, just because that way we have a chance for it to kind of overrun our supplies a bit, or to reduce the supplies quite a bit. So we have that. Now, so what we have to do is we have to find each constituent resource, which means we need to pull out, so for each vector pair string int we'll call it commodity com, or part, I guess. So I think we can just say craft item dot second, and it shouldn't. So for each vector pair string int part in craft item second, No suitable defined conversion for pair std string int to vector pair string int. Allocator vector or allocator pair string int. Because why? So for each vector of a pair string int, 1, 2, closes that off. Craft item is a string. Okay, so I think what we need to do is oh, I know why. We don't need to do that. Because it's, yeah, this is what we need to do. Dir. There we go. There we go. We were trying to re-vector it or something, and that's how it was working. Duh. Alright, so, that would have been nice to do, have it be parts. Because that would make a little bit more sense, I guess. But this works too. Actually, you know what? I'm going to do that because that makes way more sense in terms of just how this looks in terms of being able to read it. I mean, this is sound the way we have it now, but it's a little harder to read and understand than if we said a vector of pair string int parts equals craft item dot second, and then if we said in parts. So basically, for every part that's part of the craft item. So you have a craft item, you have the name of the craft item, which is the key of the pair. The value of the pair are the parts that make that craft item. So for every part in parts, again, which it just makes more sense that way. So what we need to do now is we need to take the key, take the string, and take the value and do checking based on it. First of all, we need to say if so okay, this is gonna get a little bit nasty, but it's gonna have to be this way. So for, and well, do we need to do iteration or can we do a for each here as well? So here's the thing now. So this is basically checking to make sure that we can do something. Now, we have to do this checking before we actually do the actual changing to it, because if, well, let's see, could we do that as part of, well, we have to check each part. We can't just check one part and then remove it and then do the next part. We have to say, do we have enough parts for this? So maybe what we do is, just to make this a little less complicated, void sd proc check parts. And what we'll do is this will become a private function. And then what we'll do is we will throw this in here, and actually it won't be a void. Now that I think about it, it'll have to be a bool. So it's going to return this, basically. And this way we don't have to have this over there. So I'll make this process SD a little less complicated. Oh, we don't need that here. Okay. So instead of while, this will be if. So if check parts returns true. So if we check out what we need to make it, and we can make it, And of course this is going to go up here instead of in there. Actually, then we also need to, I'm kind of getting a little bit ahead of myself here. We need to actually put stuff where it belongs. Alright, there we go. So check parts, then don't need that. Actually, I stand corrected. I was right. So if check parts, so for each item that we're going to craft, we have a thing here, then we have this. And then we take this out. So check parts. So what we need to pass through is craft item. So we need to pass through a pair of string vector pair string. String int. Let's call it item. Let's grab this real quick. So every craft item, we're going to check this. And if it checks out, so if we have all the parts we need to make it, then actually we need to also pass through end items as well. Now that I think about it. Whoa, cancel the wrong thing. Alright. So, alright, so we have this. Oh, because we have, no, it's, so what is this? This, oh. Yeah. It's tabbed out a little too much. Alright. So, SD proc, then SC proc. Alright, so, while fabrication is valid, false, so while it's not valid, while the fabrication is invalid, don't need this because we're not going to change that every time. Actually, yes we are. I stand corrected. Well, let me see. So number of items, check parts. So what if we create an output value? So instead of this, we'll call it output. And let me check to make sure I'm doing this correct, because I've done it before. And it's really awesome to do it this way because it makes things a little bit easier to handle instead of having to try and return multiple things in like a vector or something. Where would that be at? That's got to be in the database somewhere. Database handling. It's not going to be in this, so it'll be in, let's go close this. It's going to be in the, either the economic proof of concept or the proof of concept. So, data system. I think it's going to be the economy proof of concept. That's the newest thing that I have. Close this solution, rather. Open project solution 17. Ah. Alright. I think it's just this. Or not. No, I guess it is the other one. Come on. It's another thing about having the start menu on the side as you hit it sometimes, going for the command menus. I guess it is going to be this then. Alright, so database. Or data system, rather. Alright, so we're control find. No, it's not in here anywhere. You search entire solution. Cannot be executed. Well, that's interesting. Log codes. .txt. That's it. Crap. Well, at some point in time, I had done something like this, but apparently it's in somewhere else. So let's go plus C plus plus output variable. Or output parameter, rather. That's not what I want. Return value versus output parameter. Wait, I wonder if that was in, that might have been in one of my C# projects. So return a bool that also have an output parameter. So maybe that wasn't passing through pointers or something like that. Yeah, I guess that's what we'll just need to do. So, pointers. So it's come to this. Alright, so this will be an int. Expected a semicolon. If check parts, because I need to change this to a pointer. Still says expected a semicolon. Oh, up here. Of course. Of course. All right. So, now, let's just set this to 0 just for safety's sake. Because if it goes through all this and we end up with nothing being able to be made from our craft list because we don't have the materials for it, then nothing will be returned for this, so we need to have that as being 0. Or we could return it as a 0 in here, but it's easier to do it here. And that way we don't have to set end items arbitrarily to 0 or just pass it back as a 0 arbitrarily. Alright, so we have our input of our item. We're pulling out the parts for that item here, and then we're looping over each part. And then what we have to do here now is we have to go through each commodity that we have. See if the name matches. So for, we can do it each here. For each commodity, com in commodities. So now, if com, and actually also what we'll do here, or not here, inside here. So string part name equals part dot first, and then int part num equals party dot second now. Part dot second. So we pull out the name and then the number that we need. So if com dot get name equals part name. So if the part that we're looking at, so if we're looking through this and we pull up iron as the first part, we look through the commodities until we find the commodity element that's iron. Next we say if, so first what we're going to do is we're going to do the negative. So if com dot get supply is less than part num times n items, then we're going to set then we're going to set will it be valid as false, and we'll just say break. So we're going to break out of this loop. And then we'll go to the next one. Well, let's see. Let's see. Is there a way to break out of both loops? That would be best. Loop from inner loop. So for who? Must have changed their name since that comment was made. Let's go to number of loops. So harmful. What the hell? $1968. Seriously? Holy crap. people are using arguments against GoTo that were created in 1968. Yeah, I think that this just might be an excuse for people to bag on GoTo. Not that I use GoTo or would suggest you to do it, but still, basing your opinions around an article or, well, I guess it's an article. It's from whatever, I guess, magazine or some other thing from 1968, literally like 50 something years ago almost. Actually, no, 50 years ago exactly. Over 50 years. Yeah, that's, well, not at the time of this posting. Well, actually, no. I stand corrected, 49 years. Jesus Christ. Using break and go to can make more difficult reason program. See here, session about this. It's not insane. Oh, it's the person that wrote this. Edgar Dijkstra sounds like it sounds Finnish. I think it's Finnish. Finnish names are usually crazy like that. So good answers. That explains. Yeah, it's harmful meme. It's trying to generalized control flow interruption. It's harmful. Break or return. So to simulate break, you'd want, yeah, that's kind of like what the hell ishness there. So there really isn't a way. Well, there is a way, but I don't want to do it because it means creating another frigging Boolean flag for it. But if that's what it takes, that's what it takes. So be inner loop broke. It broke. It's broken. Need to fix it now. False. Alright, so for each, so after this one goes, we say if, b inner loop broke is true, meaning if there was a part that we didn't have the stuff to make it with, you know, if there's a part that didn't have the constituent stuff to make it, to be able to make it with, then we want to break out of this one too. So if we're going to break it, we're going to break it. B inner loop broke equals true. So now, if this isn't the case, we want to do an else. Well, no, we don't want to do an else. That's going to be for up here, because once we go through this, if all this is correct and works properly, nothing breaks, everything is, we have enough of a supply to make everything that we need to, then we want to go through and actually make them up here. And I don't want to put all this up here because then it gets kind of crazy with all the looping. So it's better just to do it all this in its own function that way. Alright, so we go through here, we check everything, all the parts bear out, and we have enough parts to make the constituent crafting items that we have defined by this rand here, which will get reset every time we go through if it in fact is invalid. So now, go through here. Now we want to do an else here. So if we go through this loop and it doesn't break, so if inner loop is not broken, then we want to change b fab valid to true. So for each, rather, we want to take this and put it outside of the for loop. So that's inside of the while. So if not, then set b fab valid equals true. It's very, 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 very hacky, bastardized coding, but that, don't want to do that. But it is what it is. Okay, I don't know, we don't need that. Yeah, it's pretty sure that. So, So once that's done, then we want to actually this will be a 2-liner. This has to be a 2-liner because then what we'll do is we'll say num of items equals n items. So I'll set the value of this. So if we go through here and inner loop is not broken and we can actually make the items, the number of items that we've selected to make, then we'll set that number to this. That'll get passed back through this pointer of a reference, which will set the value of this to from 0 to whatever was chosen in here, and then this will continue processing it. And then also once we're out of this loop, so this loop will happen until something is able to be created. So it'll always happen. Now here's the question though. If we don't have enough parts, period, even to make one item, how do we want to handle that? So let's say else if num items n items equals 1. So if we don't even have enough to make one item, then we want to just break out of it, and or actually we can just return false from here, can't we? So if we have a situation where we have the inner loop being broken because we don't have enough constituent parts to make a item that we're trying to craft, fabricate, whatever, and we're only trying to make one of that fabricated item, that craftable item, then we're going to say forget trying to go any further because you've hit rock bottom and there's no reason to continue. You're drunk, so go home, kind of thing. Now if we go through here and is this, we have valid is true, num items, then we're going to have it return true. Return turn. That'll work. True. Tree. Something. Alright, so if this is true, then we want to process this thing, which again we're gonna kind of do the same sort of thing, except up here. So we're gonna go through for each commodity. You've already checked this, so we don't really care about that. So for each each we're missing a couple things here. And yay, we've really just we've really screwed this up. Oh my god. Alright, first things first, this goes in here, not the other way around. Oh no, that was right. Alright. Okay, then this doesn't go here because as you can see it's throwing a crap fit about it. Instead it goes in goes here, craft item for each okay, holy crap. Yeah, I am totally just kind of lost here. Okay, so this becomes craft item. Okay, craft item, parts, parts. Now we're doing this twice. I need to do that twice. Joys of trying to bring that code up. I just, holy crap. I am totally just like massacring this right now. Oh, jeez, okay. So, We have that. Then we have this. Okay, I think we're good now. For all that craziness. So if get part name is part name, get name is part name, then com dot update supply. So the operation is going to be subtract sub, and then part num times num items. Okay, so that'll handle all that. So now once that's done, we need to then say, so this is kind of a hacky way to do it. It's kind of not really, we can do it, and it's going to be awesome to do it this way, but in the general flow of how this is going, this is kind of like putting the cart before the horse after attaching a horse to the back of the cart kind of situation. Doesn't make much sense. So, but else if com dot get name equals. Now in this case though, we're going to say craft item. Actually, we can say craft item dot first. So if this item is the item we're crafting, this way we don't have to do another for loop. We do it in here. It's kind of hacky, but we can do it this way. And then say com dot update supply. Then say one thing we need to do we'll deal with that in a second. If there's an item that's craftable, we don't want to increase it in the process commodities. Something we don't want to do. We only want to have it be created by consuming other commodities. So add, and then by num items. Okay. Now up here, commodities. So if how can we? I think it's contains. See if map contains a key. Because you don't want to like do a push or a look for it or something. And if it's not there, it's going to throw an error. Let's see. Contains key. Const. C++ 20. So let me see. Let's go back here real quick. C++. Map dot contains. Map.count key, return 0 or 1. Alternatively, .find cycle map end works too. On GCC, I don't know, map counts remove this find. I guess, yeah, we can use find then. Count is interesting, but if it calls find anyway, yeah. So, So find an equal map. Okay, so the map, which is craft list dot find com dot get name. It's not equal craft list dot, what was it, map end dot end. Rather, I'm going to go the opposite way. So if it doesn't exist in the map, that means it's not a craftable item, which means we can do this. Hopefully that works. I guess we'll find out. Alright, so if you have a craftable item, we only want it to be increased by actually creating it. Otherwise, the constituent base commodities are increased. And we have the supply demand. Alright, now, so here's the other thing now. Now that we've created steel, we need to update that to reflect that. And also, so we've added steel, which means we need to increase the supply, which we've done, but we also have to drop the demand. So com.update demand sub, and then num items, I think. I have to do the opposite here. Com.update demand add, and then this. So here's a question though that we may want to ask: is should these be able to be negative? I think so. So let's make these positive. Let's do it this way. So that way we can have. Still, I mean it's kind of hacky, because if you want to say make this a real economic system, supply should only go down when something is made, and demand should only go up when something is consumed. And demand should go down when it's created, and supply should go up when it's okay. So something's created, supply goes up, demand goes down for that item, but for the items that were consumed to make it, supply goes down, demand goes up, which is what we're doing here. So perhaps we need to shrink this down a little bit more. Maybe make this, say, -5 to 7 and -7 to 3. Just have it be a little less impactful on it, and have it mostly coming from here, but add some variability, so it's not just consistently just RNGing the hell out of itself. Alright. So now we have all that. We need to deal with the actual value of it now. So we have to determine some sort of scale that we want to use. So it's definitely have to be based on a percentage of the available supply to the current demand. So whatever percentage supplies of demand, take that percentage and multiply it by the base value of, or the current value of the commodity. Now here's where I think maybe we need to have a base value, because I think maybe if we do it just as a floating value that gets modified all the time, that it could end up going really high or really low, or other weird things. I think we maybe need to have a base value to then use it for the calculation to base the actual value off of, based on the sliding percentage. But we'll see what happens. We won't do that first. We'll do it just with the actual floating value of it first, and see what happens. So once we do this and once we do this, we then have to process the value. So let's go back over here to this and void process com value, or update com. We'll say update com values. So now what we need to do is we need to, first of all, one thing I really probably should look at before we go too much further is going to be truncating truncate flips to 2 decimals. Rounding whatever. Round F, define round F, float. So I guess we could use that. Round F. So what we want to do now is we want to say, let's see, float and C. Okay, so we need to have the actual float value first. So we need to actually generate that. So to get a percentage of something, it's the larger into the smaller, I believe. So if I said like, yeah, smaller divided by the larger, I mean. So, but let's say though, let's say it actually is larger. Let's say the supply is 100 and the demand is 50. Then yeah, that would be 2. So that would be 200%, which means that the value, the price of the commodity would go down by 200%. So, like for example, to give an example now, let's say that we have a commodity that's worth $5, just use dollars, and the demand for the item is half of what the supply is. That means that the value of that commodity would be $2.50. Because you have double the supply of what people want, so it's basically not enough people are buying it, so the value goes down. Now, if you're using the voodoo of supply side economics, then all that crap goes out the window and you use some stupid BS to justify marking the price up by X number of actual whole numbers because you're functioning on phony math, but that's not the it's not what we're going to be doing here. So we're going to actually be doing a real economic system, not some phony, scammy pyramid scheme. And actually, I just realized this is not quite right. Because, that's because that wasn't pushed in enough. Alright, so what we need to do now is we need to, again, do another one of these loops for each commodity. So, next we want to have a float. We'll call it float. I guess we'll just call it val multi or something. Equals com.getSupply divided by com.getDemand. So we have that. Now comes our awesome defined thing here that this person wrote. That Mo wrote. So round F. So then we just do basically floats, final mult, we'll say fin multi equals round f val multi 100. So that'll get us our proper percentage there. So if it's a 2, if we get a 2, actual 2 out of this, so like if I go back over to our calculator real quick, putting it through this, so if we go, where's the actual formula? There it is. So if we go 1, 2, so the float, which is the first parameter, so 2. I'm showing you how to hack the calculator here to do this awesome stuff, times 100. And actually, you don't even need all that stuff. Ah, come on. So let's try this again. So 2 times 100. Okay, that's kind of annoying. 2, you used to be able to modify what's in there. Oh, that's interesting, but this is putting out an int, not a float. That's why. And as a float, this should come out as 2.00. Well, I guess it is proper, I suppose. Yeah. But in case of other things, it'll come out the way we were expecting it to. Anyway, so we have that. Now what we need to do is we need to multiply the value times this. Or, so we have our 2 here, divided by 5. So 0.4. So if we have 5 divided by 2, okay, so the value of it divided by the new value. So 5 divided by, what if it's that? Well, that still works too. Now well, it'll work that way too. So if it's 0.5, then that means you go up by 10, up to 10. It basically doubles it. So that'll work that way. That works, yeah. So if the percentage of the supply is half of what the demand is, then the value doubles. Of the value of the commodity will double. That's exactly what we want. So com.update value. Obviously we're going to do div, and we're going to pass through fin multi. Well, there could be a problem there, because over in commodity we're expecting an int. Oh, never mind, it is a float. Never mind. That works good. I thought ahead without actually thinking ahead. Sometimes that takes a bit of effort. So else if, now in this case, since we're multiplying or whatever, we're passing through a multiple of the actual value of it that it is now, we don't need to do anything with the actual value other than divide it by the new value. So it makes it kind of easy. So com value divided by new val divided equals. Don't get to use divided equals that often. It's a red letter day. Okay, and that'll take care of the cost updates. And I think that's where we're going to end it at for tonight. Tomorrow we'll do some more streaming, and we'll actually see what happens when we try to run it after we set up the outputting, so we can actually see what's going on in the console, rather than just running it and having to do breakpoints and checking it that way. Which you might have to do if something breaks, so you might have to do it that way anyway. But thanks for tuning in. If you watched this live, if you're watching it again afterwards on YouTube, feel free to leave any comments or questions below. And if you haven't done so already, appreciate it. Subscribe to the channel, and I will see you next time.